Okay, today's objective is to solve polynomial equations by factoring. Remember that when we're solving, we're looking for things called the solutions, the roots, the zeros, which are all fancy ways of saying the x-intercepts. We want to know, when does this polynomial cross the x-axis? So, today's problems are all going to be solved using factoring. We're going to start off by factoring. We might use a different method later. We might throw in the quadratic formula after we factor. We might square root after we factor. But every problem is going to begin by factoring. So I need 0 on the right. I'm going to move everything else over to the left. So I have 2x to the 4th plus 20x squared plus 50 is equal to 0. Alright, then I'm going to factor out my greatest common factor. So 2 times x to the 4th plus 10x squared plus 25 is equal to 0. I'm going to keep going with that factoring. The x to the 4th is going to split up into x squared times x squared. Just like x squared split up into x times x, x to the 4th splits up into x squared times x squared. I look at my c sign, which is positive. So because it's positive, I know both signs are going to be our b sign, which is also positive. So both signs are plus. And then my factors of 25 are 1 and 25 and 5 and 5. I'm looking to make 10. So 1 and 25 would make 26, but 5 and 5 would make 10. Okay, after I factor, we set all of our factors equal to 0. The greatest common factor equals 0. The x squared plus 5 is equal to 0. And the x squared plus 5 is equal to 0. We set everything equal to 0, and then we solve. Our greatest common factor doesn't tell us anything at this time. It might eventually, but not right now. I'm going to solve the middle one by subtracting 5 from both sides. And then I square root. I get x is equal to plus or minus I radical 5. I'm going to do the same thing with the second one, so subtract 5 from both sides, square root, and we get plus or minus I radical 5. They are the same answer, but notice that we do have 4 answers. We have positive I radical 5, and negative I radical 5. We have positive I radical 5 and negative I radical 5. So those are our 4 answers, which goes with our degree of 4. So 2x to the 4th tells us that we should have our 4 answers. Okay, please pause this video now so that you can try problem number 2. Okay, so after I moved the 21 to the left side, it factored into 2x squared minus 3 times x squared plus 7. I set both factors equal to 0. When I solved the first one, 2x squared minus 3, I add 3 to both sides and divide by 2. Remember, when we take the square root of a fraction, we take the square root of both the numerator and the denominator. We rationalize the denominator, and so I got plus or minus radical 6 over 2. For the other factor, x squared plus 7, I subtracted 7 from both sides, and then I square rooted. X is equal to plus or minus I radical 7. Okay. At first glance, you might think that this is a solve by square root problem. We cannot square root this problem because we do not have an x squared term. You cannot square root if you don't have x squared. Because it's x to the 4th, we do have to solve by factoring. So the steps are going to be the same. I'm going to move the 81 over to the left. So 16x to the 4th minus 81 is equal to 0. This type of factoring is going to be our perfect square factoring. So we don't have a b term, and c is positive, which means that I'm going to have 1 plus and 1 minus. And then it's just our perfect square. So the square root of 16x to the 4th is 4x squared. So 4x squared is the first term in both parentheses. The square root of 81 is 9, so 9 is the second term in both sets of parentheses. I'm going to look at my two sets of parentheses. Can I factor either of them any further? I notice that 4x squared minus 9 is still a set of perfect squares. So I'm going to leave 4x squared plus 9. But now I get 2x plus 3 and 2x minus 3. Using the same factoring method, I did the square root of 4x squared to get 2x. I did the square root of 9 to get 3. I knew that one was positive and one was negative. Now that I'm totally done factoring, I'm going to set all my parts equal to 0. So 4x squared plus 9 equals 0, 2x plus 3 equals 0, and 2x minus 3 equals 0. I'm going to solve all three pieces. So we subtract 9 from both sides. We divide by 4. I square root both sides by square rooting the numerator and denominator. I get x is equal to plus or minus. This time they both simplify, so I get 3i in the numerator and 2 in the denominator. I'm going to go to that middle factor, so we subtract 3 and divide by 2. On the right, we add 3 and divide by 2. Again, I'd like to point out our degree is 4 because my highest exponent is 4, and I have 4 answers. I have 3 halves, negative 3 halves, positive 3i over 2, and negative 3i over 2. Those are our 4 answers. Just like before, I want you to try number 4 by pausing this video and then checking your answer when you're finished. Okay, similar to number 3, I factored using perfect squares, so it became 6x squared plus 5 and 6x squared minus 5 is equal to 0. Neither of them factored any further, so I went ahead and set them both equal to 0. I solved the left factor first by subtracting 5 and divided by 6. We took the square root of both sides and had to rationalize the denominator to get plus or minus I radical 30 over 6. Then I solved the right factor by adding 5 and dividing by 6. When I take the square root of both sides, I had to rationalize to get plus or minus 30, or radical 30 over 6. Okay, our next type of factoring is factoring using perfect cubes. Again, we can't use the square root method because it's not a perfect square. This time it's a cube. So we're going to factor using our cube method. That's SOAP. Same, opposite, always positive. That's what we're going to do to factor today. So first we add the 125 to both sides. 8x cubed plus 125 is equal to 0. Remember, we find our roots. So the cubed root of 8x cubed is 8x, and the cubed root of 125 is 5. So we make our two parentheses. We have our small parentheses and our longer parentheses. I do 8x and 5. I square the first term to get 64x squared. I multiply them together to get 40x. And I square the last term to get 25. And our signs are same, opposite, always positive. Okay, so after I factor the cubes, I set each part equal to 0. Remember, I mentioned this when we were doing our factoring earlier, but just a reminder, the 64x squared minus 40x plus 25, that will never factor. It is always a prime trinomial, so it never factors, which means that when I set everything equal to 0, I'm going to have to use the quadratic formula for that trinomial. So every time, if it's a perfect cube problem, you're going to have an easy problem where I subtract 5 from both sides and divide by 8. And you're going to have a little more difficult problem where you have to use the quadratic formula. So x is equal to, this time positive 40 plus or minus the square root of 1600 minus 4 times 64 times 25, all over 2 times 64. So x is equal to 40 plus or minus the square root of negative 4800 all over 128. I can shoot out an I. Sorry about that. And 4800 splits into 1603. 1600 is a perfect square. It's 40 times 40. So we get, I'm going to put it up at the top so I have a little bit of room. X is equal to 40 plus or minus the square root, sorry, no it's not, plus or minus 40i radical 3 all over 128. I can simplify that magic triangle by dividing them all by 8. So we get x is equal to 5 plus or minus 5i radical 3 over 16. Just like in the problems before, we had x to the 4th and we got 4 answers. In the last two problems we had x to the 4th and we got 4 answers. In this problem we had x cubed and we have 3 answers. Negative 5/8 and 5 plus or minus 5i radical 3 over 16. Okay, let's try another one like that. So first we factor using our cube root. So the roots are x and 3. My binomial is going to be x and 3. The trinomial, we square the first term, we multiply the terms together, we square the last. Our signs are same, opposite, always positive. Then we set our factors equal to 0. And then we solve. I am going to add 3 to both sides to get x equals 3. X squared plus 3x plus 9. It will not factor, so we must use the quadratic formula. We get negative 3 plus or minus the square root of 9 minus 4 times 1 times 9 all over 2 times 1. So we get negative 3 plus or minus the square root of negative 27 all over 2. The shoot out an I, we get 9 times 3, which is 3 times 3. So we get x is equal to negative 3 plus or minus 3i radical 3 over 2. I do a little double check. It's an x to the 3rd problem. I have 3 answers. 3 and negative 3 plus or minus 3i radical 3 over 2. Our factoring was perfect cubes. Same, opposite, always positive. Alright, just like before, I want you to pause right here and try number 7 on your own. Alright, you should have gotten negative 1/4 and 1 plus or minus I radical 3 over 8. So it factored into 4x plus 1 and 16x squared minus 4x plus 1. I solved the first one by setting it equal to 0 and solving for x. Solve the second one using the quadratic formula. Okay, and the last type of factoring that we've done this year is factoring by grouping. So just like before, we want to get everything on the right, on the left, and 0 on the right. So I'm going to move 28. 3x cubed plus 7x squared minus 12x minus 28 is equal to 0. Remember, factor by grouping. We split it in half. And I look at the first two terms, 3x cubed and 7x squared. I can factor an x squared out, and I'm left with 3x plus 7. When I look at the second two terms, negative 12x and negative 28, I want 3x plus 7. So I have to think, what can I factor out of negative 12x and negative 28 so that I have 3x plus 7? I have to factor out that negative 4. So then my factors, I have 3x plus 7 in common, and my leftovers are x squared minus 4. Once I write those factors down, I notice I have x squared minus 4, which does factor further. We get 3x plus 7. It's a difference of perfect squares, so it becomes x plus 2 and x minus 2. Now that everything is completely factored, I set all my parts equal to 0. And I solve for x. So 3x equals negative 7. We get negative 7 thirds. Subtract 2 from both sides to get negative 2. Add 2 to both sides to get 2. I began with x to the third. X to the third is my highest exponent, which is our degree, and I do have 3 answers. Okay, so negative 7 thirds, negative 2, and 2. Let's try another one together. No, sorry. I'd like for you to try this one on your own. Please pause here. Alright, my 3 solutions are plus or minus I radical 3 over 3 and x equals 3 halves. Remember, when you're factoring by grouping, you always have to factor something. So on the right side, even though I already had 2x minus 3, I had to factor out that 1. That way I had 3x squared plus 1 and 2x minus 3. Okay, we have one more type of problem left to try. So in this problem, I have 3x to the 7th equals 81x to the 4th. We're still solving by factoring. I cannot take the square root of both sides, mainly because I don't have an x squared term to square root, but also because our highest degree is 7, which means that we should get 7 answers. So first I'm going to move the 81x to the 4th. So 3x to the 7th minus 81x to the 4th is equal to 0. I'm going to factor out my greatest common factor. It looks like I can take out a 3 and an x to the 4th. So we get x cubed minus 27. X cubed minus 27 factors a little further. So 3x to the 4th, it's perfect cube, so we get x and 3. We get x squared, 3x, 9. My signs are same, opposite, always positive. Okay, now that I have factored, I'm going to set each factor equal to 0. For my first factor, when I divide by 3, I get x to the 4th is equal to 0. When I take the 4th root of something, I get x is still equal to 0. Technically, we have 4 zeros right there because we're taking the 4th root, but one of our answers is x equals 0. I find another answer in the middle by adding 3 to both sides to get x equals 3. And on the right, it doesn't factor any further. I can't use the square root method. I must use the quadratic formula. So we get negative 3 plus or minus the square root of 9 minus 4 times 1 times 9 all over 2 times 1. So negative 3 plus or minus the square root of negative 27 over 2, which simplifies into negative 3 plus or minus 3i radical 3 over 2. I remember the 3i radical 3 from the problem that we did earlier, but if you missed it, it's an I here. It's, 27 is 9 times 3. 3 is 9 times 9. All right, so I am supposed to have 7 answers because my degree is 7. I have 2 answers after the quadratic formula. I have 1 answer after the x minus 3 factor, and I technically have 4 zeros. So those are my 7 answers. All right, we have one more problem. I want you to move to the next problem, try 11 on your own, and then check your answer. Okay, I factored out a 3x cubed to get 3x cubed times 2x squared plus 5. I set both factors equal to 0. The 3x cubed gives me a solution of 0. And then I solved using the square root method for the second part. I subtracted 5 from both sides, divided by 2. I square rooted, and so I had to rationalize, and I got plus or minus I radical 10 over 2. So for problems like this, we can factor. We factor first, and then we have to use one of our other methods in order to continue our solving.